Dua, tiga.
Assalamualaikum and good evening. My name is Muhammad Dan Adam bin Muhammad Najib.
My name is Zikul Rizzi bin Faizi.
And my name is Muhammad Syafiq bin Khairuddin.
And my name is Jayaprakash.
Um, we are from bmIM 3154 Assembly Method, and today we will present our DFMA case study titled Engineering Efficiency Optimizing the City Truck Through Design for Manufacturing and Assembly. Our project focused on analyzing a toy city truck using the FMA principle. The objective is to simplify its design by reducing unnecessary components while maintaining the product function and quality. By doing this, we aim to reduce assembly time, lower manufacturing costs, and improve overall production efficiency. Now let's begin with an overview of the original product. This slide summarizes our project result. Initially, the city truck contained 8 separate components that require individual assembly. After applying the FMA principle, we successfully reduced the number of critical components to 4 integrated modules, representing a 50% reduction in part count. As a result, the design efficiency increased significantly from 0.129 to 0.252, which is approximately a 95% improvement. This demonstrates that reducing unnecessary components can greatly improve manufacturing efficiency. Before making any improvement, we first analyze the product structure. Consists of 4 main assemblies. The first is the chassis assembly, which form the main supporting structure. The second is truck body assembly, which include the truck cab and exterior housing. The third is container assembly, which form the rear cargo compartment. Finally, mechanism assembly contain the wheel, gear, and moving component. Understanding this original structure will help us identify which component could be combined during the design. Now, I will hand over the presentation to presenter number 2.
Okay, thank you, Presenter Adam. Now I would like to talk about the diagnosis. Our diagnosis about the teardown. At this stage, our analysis was product 3, teardown. We carefully deassemble the city truck into the individual part. During this process, we separate the container, remove the truck body, deassemble the wheel assemblies, and isolate the internal gears and washer. The teardown, this teardown allow us to observe how every component was assembled and identify the unnecessary assembly steps. We discovered that several parts that only serve structural purpose and could potentially be merged. Next slide. Okay, now I would like to talk about our product tree structure. After the teardown, we create the product structure tree. The structure tree clearly show the every component used in the original design. The product consists of many independent parts, including the chassis, truck cab, truck head, grill guard, tires, rim, container, base container, gears, and washer. From this structure, we identify that component that could be permanently integrated during the manufacturing without affecting the product functionality. Okay, next slide, please. Uh, this is how we use evaluate our product using the DFMA metric. The original design contained 8 separate target components. The total manual assembly time was 92.73 seconds. Using the Brotherhood method DFMA formula, the design efficiency was only at the 0.129, indicating that the assembly process was insufficient. The main problem identified were excessive handling and multi-insertion option because the every component had to pick up individually and assembly individually. This finding became our basis for our redesign strategy. Now I will pass to presenter 3.
Thank you, Japik, for your presentation. The FMA improvement strategy. Based on our analysis, we propose combine several adjusting components into a single integrated module. The objective was to eliminate unnecessary assembly operation. For new integrated module, we create the grill guard and chassis become one from an unit. The truck head and truck cab become one operator housing. The tire and rim become one wheel module. Finally, the container and base container become one cargo module. This significantly reduce both handling and section operations. Next slide. Structural integration. This slide illustrates the structural integrated process. Instead of assembling the grill guard separately onto the chassis, both the components are manufactured as one unified part. Similarly, the truck head and truck cab are combined into a single housing. These redesigns improve to complicate alignment and assembly operation while maintaining the same appearance and structural strength. Next slide. Functional integrations. Besides structural improvement, we also integrated several functional components. The tire and rim are molded together into one wheel module. Likewise, the container and base container are manufactured as a single cargo module. This redesign removed difficult manual insertion steps, reduced assembly error, and improved production consistency. Now, I would like to invite Presenter 4 to continue. Jay?
Thank you, President Z. After completing the design process or integration component or model using SolidWorks, from the final 3D modeling engineering were created to show requirement dimension, tolerance, and manufacturing details. This drawing helps us to ensure that even though the number of components was reduced, the redesign of still maintained the requirement strength on function. The drawing also refers to the future manufacturing and product process. Next slide. Performance comparison. Next, this slide shows that comparison between the original design and the redesign. From the analysis of the number, the component was reduced from 8 components to only 4 components. The assembly time was also improved redesigned from 92.73 seconds and 47.59 seconds, which is almost to 50% reduction in assembly time. Besides that, the design eventually increased from 0.129 to 0.252. This shows that applying DFMA principle helps to simplify the product structure, reduce assembly steps, and improve overall manufacturing efficiency. Next slide. In conclusion, this project successfully shows the advantage derived from manufacturing and assembly. Through component reduction and part swap, the redesigned product achieved faster assembly time while maintaining the requirement functionality. This project also improved the understanding of DFMA, concept product, evaluation, SCAD modeling, engineering drawing, and teamwork. Overall and well-designed product can reduce production time, simplify manufacturing process, and help lower overall production. Thank you for your attention.